explain how Darwin's theory explains some of these complex systems. Now, what types of complex systems, just for people listening, what do you mean?
Well, think about the blood clotting cascade. Blood clotting cascade. What's that mean? A guy gets up in the morning, goes to shave, and you nick yourself a little bit, and a little trickle of blood comes out and slows down and stops. What's the big deal? Well, it turns out that even back then, even back in the 80s, we knew that blood clotting was an extremely complicated process. And it has to be because it's not so much forming the little glob to stop blood, it's the timing and the placement. Because if your blood clots at the wrong time in the wrong place, you're in big trouble.
If your blood clots inside your body, you die.
Exactly. Or a clot goes to your heart or your brain and so on. And it turns out that there's a substance called fibrinogen. Fibrin, which is the stuff of the clot material itself. It's kind of like the clot when it forms is kind of like a fisherman's net, cross like this, and it traps red blood cells and slows it down and stops the bleeding.
I see. I've never heard this. I take clotting for granted.
Yeah, yes, we all do. We all have, but it turns out not to be as simple as you think. But if fibrin was in your blood just as fibrin, then all your blood would be clotted and you would kind of be stiff.
You'd be born dead.
Yeah.
Okay.
So it's actually present as an inactive form called fibrinogen, and that has to be activated. And it's activated by another protein called thrombin coming over, clipping off a little piece of the fibrinogen, which exposes a site that allows it to stick to other copies of fibrin and form this meshwork.
So what is this other piece? Not the fibrin, but the other piece?
It's called thrombin.
Okay, thrombin, does that exist in blood already?
Yes.
Okay, and what activates the thrombin? I feel like we're going backwards and backwards.
Exactly. If thrombin was there and was active all the time, then it would clip off the fibrinogen and you'd be in the same pickle.
Okay, so what is it about blood coming out of your body? Does it react with something in the atmosphere?
That's right. Well, when you get a cut, some of the insides of a cell are exposed that normally aren't exposed to blood. And there are factors which recognize that, and they initiate what's called the blood clotting cascade, which is where one factor activates the next factor, which activates the next one, and so on. That factor thrombin that I mentioned is actually present as prothrombin, inactive, but it has to be activated by another factor and so on.
But the other factor, because we're going backwards, you have the fibrin, the thrombin, but you're saying that there is something that kicks off the thrombin, that catalyzes it into being active.
Right.
What is that? Is that something when you cut your skin, some of those cells do that?
Yes. On the inside of your cell's membranes, which are not normally exposed, there are substances which the blood clotting proteins recognize as not supposed to be there, and they stick to them. And when they stick to them, they change shape a little bit, and the next factor down the line sticks to that, and then it can activate the one after that, and so on.
Okay, that alone is amazing, because I have never thought about what actually happens when blood clots. Mm-hmm. Not that I understand it fully, obviously, but just to hear you say this, it does sound extremely complex and amazing, absolutely amazing. It's the sort of thing that would make me think, wow, there must be a God. Who in the world came up with that? Yeah. That this thing happens and this thing happens and this thing happens. When we come back, we're going to continue the conversation with Dr. Michael Behe. The book is Darwin Devolves. Brand new book, brand new science. You need to know the cutting edge science. You can read the book. We'll be right back. It's the Eric Metaxas Show.
Nothing seems to fit.
Hey there, folks. That's BJ Thomas. I'm Eric Metaxas, and I'm talking to Dr. Michael Behe, the author of a brand new book. The old book is Darwin's Black Box. The new one Darwin Devolves. Incredibly important thesis dealing with new science. But we were just talking about your story of how did you come to begin thinking that Darwin maybe is not explaining everything? And you're giving us this example of how blood coagulates. I'm in awe of this description. And so what do strict Darwinianists say about this? They actually believe that random mutations would lead to this? I guess they do.
Yes, they do, and they believed it even before they knew what it looked like. So it turns out that some of the proteins in the clotting cascade are similar to other of the proteins in the clotting cascade. So the typical approach for our Darwinian is to say, well, all the ones that look alike, well, they probably arose from some ancestor protein that accidentally duplicated
Right.
when the cell replicated. But with the clotting cascade, that's a problem, because if you duplicate something that is already working, then it's going to turn the clotting cascade on, and you'll be in big trouble. And if you make something new that can't be activated, then it won't turn the clotting cascade on at the right time. So just saying, well, these things sort of kind of look like each other, therefore they arose randomly is far from an explanation.
So you're already an established scientist in the late '80s. You're looking at this stuff, and it must have been disturbing to you because you realize the entire scientific establishment doesn't like people questioning Darwin.
Yeah, that's you get that